Hello there, this is Manoj. I hope you are doing well. After we discussed in our last video about various transformer parts and their uses, it is now time to talk about the different tests that we will be performing inside our lab. So, which is the first test that we will perform? Well, we will be performing the insulation resistance test. It is also known by the name of IR test, or people like to call it Megger test. But mind you, Megger is the name of the company that produces the equipment which is used to measure the insulation resistance. So it is always valid to say insulation resistance test than Megger test. Remember that. This is a discussion session. At the end of this session, we both should know what exactly is the insulation resistance, when exactly is this insulation test performed, and why. Also, we will learn that how exactly is this insulation resistance test done. Those are the learning outcomes of this video. So if you are ready to begin, let's talk. So what is the purpose of insulation resistance test? It is very simple actually. Just imagine that a transformer has two types of parts, just like any other electrical equipment. I will first explain you the logic behind this IR test, and then we will move forward with the technicality. So there are two types of parts in any electrical device. There are two types of parts in transformer also, and those two types of parts are nothing but the conductive parts, which carry the electrical current, and the non-conductive parts, which do not carry any type of electrical current. The non-conductive parts are always the outside of the electrical equipment. In our case, it is our transformer body. In our houses, we will be having a refrigerator, and the surface of the refrigerator is a non-conductive part. But we know that there are some electrical equipment inside a refrigerator, electrical parts, which will be carrying electrical current. So those are the conducting parts. In case of transformer, I hope by now you know that which parts of transformer are conducting parts. Well, you've guessed it right. Transformer windings and to an extent transformer core are the conducting parts, because talking about the high voltage winding, we apply a high voltage across our winding, which results in the flow of primary current, which is 16 ampere, 16.53 ampere in our case. And on the low voltage side, a step down voltage of 433 volts is getting produced, which is causing flow of almost 420 ampere current in the low voltage winding. So we now know that windings and core constitute conducting parts of a transformer. What are the non-conducting parts of transformer? Non-conducting parts of transformer are nothing but the transformer body, the body of the transformer. It is always considered as a non-conducting part of any transformer because it is exposed to the environment. Now imagine what will happen if the conducting parts and the non-conducting parts get connected. A very unsafe scenario, so to say. If a high voltage winding gets connected to the transformer body somehow from the inside, it will result into a ground fault. The entire high voltage will get connected to transformer body, which is placed on the ground, which will cause a severe ground fault. Similar thing will happen in case of low voltage winding. Also, if a low voltage winding and a high voltage winding get connected electrically, what will happen? Again, a very unsafe scenario. It will be a face-to-face fault. So all the conducting parts and the non-conducting parts, even different conducting parts, need to be isolated or insulated in a dielectric manner, so that the transformer functions as per its requirement, as per its design, and as per the needs. Insulation resistance is the measure of that insulation between conducting and non-conducting parts of the transformer. It is a unit to measure the insulation resistance between the conducting and non-conducting parts. So, in a simple way, we can just measure the IR of a transformer and predict whether the transformer has adequate insulation or it is not having adequate insulation. I hope the concept of insulation resistance is getting clear step by step. There are some points I have jotted down in our booklet, which will also put some light on the concept of insulation resistance. So, what is the purpose of IR test? It is to measure the dielectric strength of transformer. As I said, the presence of insulation between the conducting and non-conducting parts can be measured. That is the dielectric strength. And how exactly is this test performed? Well, we apply a measured DC voltage across the conducting and non-conducting parts, and then we measure the leakage current which flows because of the application of DC current or DC voltage. That is the way to calculate the resistance. Okay, so we will be having voltage which we have applied. We will measure the leakage current that will be passed between the conducting and non-conducting parts, and then we will apply Ohm's law, that is V is equal to IR, so that we can find out the resistance, and that resistance is called as insulation resistance. But how we will know whether the insulation resistance is enough or not? To this, there is a thumb rule that for every kilovolt of the rating of equipment, the insulation resistance should be 1 mega ohm. 1 mega ohm. So, as a thumb rule, just remember that ideally the insulation resistance should be as high as it can be. Ideally, it is said that the insulation resistance is infinite. That's the ideal condition. Okay, for how long do we need to apply this voltage between the conducting and non-conducting parts? The answer is 15 seconds, 1 minute, or 10 minutes. Basically, anything beyond 1 minute is a good example, as when we apply voltage between the conducting and non-conducting part, there is a insulation between them, and when this voltage is applied, there are two types of currents that flow because of the voltage. One is called as the leakage current, which flows on the surface of that insulation. For example, the insulation can be the bushing, so the leakage current can flow on the surface of the insulation due to the presence of dust or moisture. And the second type of current is the current that flows through the volume of the insulation. So these currents consists of instantaneous elements also, which decay with time. So if we take a reading after 1 minute, such factors get decayed and we get an accurate reading. So that's why it is always good to conduct this test for 1 minute duration or 10 minutes duration also, depending upon the equipment rating and suitability. I hope that you have an idea, certain idea about the insulation resistance and the insulation resistance test method. So if you are comfortable, let's move inside our lab and perform this test. So if you are ready, I will see you in the lab. If you still have any questions, then hit me up on my LinkedIn and get in touch with me. Let's discuss what are the queries you are having about the insulation resistance, and I will attempt on clarifying those queries for you. Okay.